So guys, I forgot to talk to you about boat conformations, and there's really not much to say about it. To bring up my molecule here. So here we have a chair conformation. A boat conformation is when we have the rotation of one of the carbons rotating, flipping up or down. I guess it's relative, right? Now, the problem with this, if you see that, is you got some steric hindrance up in here, okay? And so usually at this point, the other carbon will rotate down, and it kind of happens at the same time. But sometimes you will have cyclohexane rings that for a period of time will exist in a boat conformation. Now, the important thing to remember is that if your groups have steric hindrance, that's going to cause your molecule to be less stable, okay? So sometimes if you have two very bulky groups, like these tert-butyl groups, because now we know tert-butyl groups are really bulky. If you have two tert-butyl groups or two very bulky groups on your ring and they are on opposite sides, in order to accommodate both of those in an equatorial-like position, you can have the ring structure go into this boat conformation. Okay, so let me color code these real quick. So for example, I'm going to make these blue. These blue represents my tert-butyl. So in this chair conformation, I have one tert-butyl group in equatorial, but I also have one in axial. So if I do a ring flip, it ends up being pretty much the same. Now this one's equatorial and this one's axial. So if you have something like this, what the molecule can do to alleviate the steric hindrance that's going on with the axial tert-butyl group is to go into a boat conformation where this bottom one sort of flips up. And now you can see both of the tert-butyl groups, I don't think these are called equatorial positions anymore. I think that's just for chair conformations, but I'm not completely sure. But you can see just by looking at the molecule that now they're being held away from the ring and away from other groups. So this is going to be the least sterically hindered conformation for this ring. And when the ring structure looks like this, you see how it kind of looks like a sailboat? We call this the boat conformation. You don't see it a lot, but so you guys know what it is, that's what it looks like, and this is how it's drawn on paper. So that's pretty much it for boat conformations.